Hey everyone, in this video of attributes of polynomials, we're going to be describing the end behavior of a polynomial. So basically the arrows. What are the arrows doing? Describing it using specific notation, and let's get to it. So far we've been talking about all of the things that qualifies a polynomial to make it special, right? The degree, the exponents, the x-intercepts, the y-intercepts, the maximums, the minimums, all of that stuff. In this video, we're going to be focusing specifically on the end behavior. Now, the end behavior is referring to the arrows. What is happening to the function as it approaches the end on the right-hand side and the left-hand side? In the middle, a lot of things can happen. You can have maximums, minimums, loops, all kinds of different things happening. What happens as a function goes to the right towards positive infinity? Here. On the right-hand side, what happens when the function goes to the right towards positive infinity? And what happens when the function goes to the left on the negative infinity? What are the arrows doing on the left and on the right? So what we're going to be doing is we're going to be using specific notation to talk about what happens when x goes to positive infinity and what happens when x goes to negative infinity. And this is the notation we're dealing with. The notation that you are going to be seeing very commonly in pre-calculus and definitely in calculus looks like this. We're going to be talking about the limit of a function as x approaches either positive infinity or negative infinity. And we're trying to describe this behavior. Okay? Now, in shorthand, we're going to be writing it like this. LIM for limit as x approaches positive infinity for the specific function. We're describing where is it going to go. Or even what is the limit of a function as x goes towards the left, the negative infinity. Where is the function going? So when you're dealing with what happens when x goes to positive infinity, it's really telling you what happens when x goes to the right. Right? Positive infinity is on the right-hand side, so we can just label this as the right. And what happens when the function goes towards negative infinity, or, in other words, the left. So you can read this however you want, right? You can read it as, what is the function doing when x goes to the right, and what is the function doing when x goes to the left? You're really just describing those arrows. Are they pointing up? Are they pointing down? What are those end behavior doing? The middle, again, craziness can occur, but what happens on the outsides, on the right side and the left side? So let's do some examples real quick. Let's cut this down the middle and show you two examples. Over here I'm going to have two different graphs, and I'm going to describe the end behavior of both. I have one that looks like this, and I have one that looks like this, just to give you an even and an odd function. Again, I'm interested in the end behavior. So let's say that my first notation looks like this. I have the limit of this function as x goes to infinity, and the limit of the function as x goes to negative infinity. Now, infinity is the right side of the graph. What is the function doing? It's pointing down towards negative infinity. So we're going to say negative infinity is my solution. What is the function doing as x goes to the left? On the left side, it's also pointing down towards negative infinity. Because both arrows are pointing down, both end values, both endpoints are pointing towards the negative infinity range. Let's look at this other one on the right side. What is the limit of the function as x goes towards positive infinity? And what is the limit of the function as x goes towards negative infinity? Well, positive infinity means the right side of the graph. On the right side, the function is going down towards negative infinity. And what is the function doing as x goes to the left or negative infinity? On the left side, the function goes up towards positive infinity. Okay, so all we're really doing here is describing the end behavior of the graph. Where are the arrows pointing as x goes to the right and as x goes to the left? And you're using this fancy notation to use it as a shortcut instead of giving you this long sentence. We're really just describing the limit. Where is the function going as it increases or as it decreases to the right and to the left? I hope this is simple enough. If it isn't, please comment below and I'll answer things for you. You guys have a great day, and as always, we'll calculate later.